Hello, welcome everybody. Here is your lesson on polynomial operations. This is the first section in Unit 7. It's a relatively easy section in terms that you'll only have to multiply, add, or subtract usually. However, knowing when to do them is often challenging for students. So I'm going to start off with these are the properties of exponents that are often challenging for students. So we'll go through all 9 of these, and these are going to be the first 9 things you'll see on your worksheet when you get to class. So the very first one I'm going to start with, I'm going to kind of start over on this side, and I'm going to start with what do you do when you have a multiplication problem. This is multiplication, and your bases of these items are the same. The bases are the a's. An example with numbers would be like 2 to the third times 2 to the fourth. Well, 2 to the third means 2 times 2 times 2, and 2 to the fourth means 2 times 2 times 2 times 2. So that would be a total of 7 2's. So basically all you have to do for a problem like this is just add your exponents. And it's not magic that it works that way. It works that way because of the, the operations and what the exponent means. So this answer is a to the m plus n. Boy, I'm going to have to squeeze this in here, but hopefully you can see that. The exponent for that case is you add. When you have a division problem, your answer is a to the m minus n. That's a subtraction right there in the middle. And then a to the 0 is always defined to be the number 1. Okay, if you're dying to know why that is, you can ask me in class. I can explain that to you. But it's just a memorized item. Anything to the 0 power is 1. A lot of people mistake that as the number 0. It's not 0, it's 1. When we move over to the middle here, and you have the parentheses where you have an exponent raised to an exponent, the operation is to multiply those, m times n. Then when you have a multiplication inside and an exponent on the outside, your shortcut here is to distribute that m into both. So it would be a to the m, and then you multiply that times b to the m. This one here, it's the same thing as the one above, except when you distribute it in, it stays as a division sign. A to the m divided by b to the m. And then we get to negative exponents. Well, negative exponents are my favorite because I love to teach it this way because students rarely forget it. If you ever see a negative exponent, just take your ear. I gotta get my ear here. Here it is. Here's my ear. Hi. All you have to do is put your ear really close to your paper and listen. Listen carefully. Maybe you can hear it. I'm going to start listening now. Here I go. Move me. Did you hear that? Anytime you see a negative exponent, just listen very carefully. Put your ear to the paper. It'll say to move me. Negative exponents mean move me. So move you where? Well, if you're in the top of a fraction, like you are here because it's over 1, you just move it to the bottom. So the a gets moved to the bottom with its exponent n, and the n just gets changed to a positive number. Now, if you're already in the bottom and you listen, move me, that means to move you to the top. So this guy here in the bottom, I'm just going to flip up to the top. So then the a to the n goes to the top. And notice how the exponent changes from negative to positive when you move it. Now for this last one, you listen again, move me. But I'm also going to start by combining this property over here by distributing that negative n to both top and bottom. And then you do a move me, so you're just going to switch places with these two, and your final answer is going to be b to the n divided by a to the n. And I know this is kind of a busy slide, but hopefully you got all those answers and you did them in sequence. A lot shorter here. I'm going to go through them real fast. I'm going to do my best to try to give you as many different strategies as I can as we go through this. This is example 1, and then I'm going to do 3 problems for example 1. The first one is just a multiplication problem, so everything you see here is multiply. You handle numbers the same way you've been doing numbers forever. So 4 times 3. 4 times 3 is 12. Now, from the last slide, whenever you see an exponent, like a to the third and a to the negative fourth, you add those exponents. So showing the work, it's going to be a to the adding of exponents is 3 plus negative 4. And then for the b, you add the exponents again. It would be b to the 2 plus negative 3. So then your answer is going to be 12, a to the negative 1, b to the negative 1. Now, any time in the process, you can press your ear to the paper and listen. Move me, move me, move me, move me. Oh, just 2 move me's there. Excuse me. So when you hear the move me, you can move them at any time. You could move them originally, but I don't like to do the move me's to the end, and I combine them with the add first, because sometimes you'll move it and then you'll combine them and then you'll have to move them back. It's kind of a pain. So I'm just going to move these 2 items. The 12 does not have a negative exponent, so it stays on the top. You have to create a bottom because there is no bottom, and the bottom is just going to be AB. Now for this one, property from exponents on the last page means you multiply these 2 together. When you have parentheses like that, it becomes x to the 2 times 0, which is 0. And anything to the 0 power is 1. And similar thing here, except you got to be really careful, because this 4 exponent goes to both the 4 and the r. So you're going to start by taking that 4 and distributing it into the 4, taking the 4 and distributing it into 0, and 0 times 4 is 0. So it's r to the 0. 4 to the 4th, that's tricky. 4 times 4 is 16. 16 times 4, 24, carry the 2, 4, 5, 64. 64 times 4 is 16, carry the 1, 24, 25, 256. That's a tricky one. Probably use a calculator for that. And then r to the 0 is 1 times 1, which is 256. Okay, so that's your exponent properties. I'm just one real quickly for you, just to kind of show you how complicated they can get. With this one, I'm going to start with the numbers, 2 over 3. Now, that could be reduced in some cases, but in this case it can't. So you leave the 2 in the top, the 3 in the bottom. I'm going to take the x's and I'm going to subtract the exponents. 4 minus 2 is 2. So I'm always going to put the answer in the top when I subtract exponents. The y's are tricky because I'm going to do negative 4 minus negative 3. When you have division, you subtract exponents from 2 slides ago. This changes to plus, and you get y to the negative 4 plus 3, which is negative 1. I will always put that answer in the top, and I'm going to move it in a second. And then the z's, you subtract exponents, and really quickly, negative 3 minus 4 is negative 7. Always put in the top, z to the negative 7. And then you listen very carefully. That's silent, that's silent, that's silent. Oh, move me, move me. So those are the 2 you have to move. So the result of this, going to put it in green to make sure you keep everything straight, 2 in the top, 3 in the bottom, x in the top, none of those move, the y moves, the z moves, and the 7 comes along and becomes a positive. Exponent properties can be tricky, and in my opinion, they're probably the number 1 or 2 error on like a standardized test like an ACT that students do wrong. After exponents, you'll have to add or subtract polynomials, and this is pretty easy. You just add or subtract their counterparts. Counterparts meaning like terms. So I'm going to underline some like terms. I'm going to start with just this in green. That is a like term with this one because it's the same letter, same power. Now you could think to yourself 12 minus negative 2a, negative 2. You could do that. Or what I like to do with subtraction problems is change them to addition and then flip all of these signs. That becomes a negative, that becomes a positive, that becomes a positive. That way I don't have to mess with negatives and I don't have to do all this. It's pretty easy then. All I have to do is look at the 12 and look at the 2. 12 plus 2 is 14. A to the 5th. Notice in multiplication you change the exponent. In addition and subtraction you do not. Changing colors to red. Here is an a to the fourth. Look for its buddy. Buddy, 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 buddy. Ooh, it has no buddies. Leave it as plus 14 a to the fourth. Changing to brown, and I'm probably going to run out of colors here. Oh, no, yes I am. So here's an a to the third. I'm trying to go in the exponent order so I catch them all. Minus 10 a to the third. And then the last one, I'll kind of circle in brown so you can see the difference. 10, that's a negative now, remember, because I changed it with the plus, with the minus sign there. Negative 10 and negative 6 is negative 16. And that's how you would subtract or add. Adding is the same way, but I wouldn't have to flip the signs. And then the last thing about is going to be multiplication. I'm going to give you the general system for multiplication, and it'll work for anything. So I know a lot of you will probably want to do FOIL here, and I perfectly teach FOIL. I'm okay with that. First outers, inners last. But I like to think of it as a double distributive property. So that way, if you have two things times three things, it works all the same. I'll take this 7x and distribute it into both pieces. So 7 times 5 is 35, x squared, x times x. And 7x times negative 4 is negative 28x. And then I'll take the 7 and distribute it into both parts. 7 times 5 is 35, and 7 times negative 4 is negative 28. These two in the middle here are like terms. 35 minus 28 is 7. And just bring those guys along for the ride. And that's how you would multiply FOIL in this case. But if you had three things like x squared plus, or x cubed plus 2x plus 1 times x minus 4, you would take this guy, put it into both. Take this guy, put it into both. And then take this last one and put it into both. FOIL, that acronym, F-O-I-L, only works when you have two things times two things. We call those binomials. That's the general sense of it. You'll definitely need to do the practice on Lesson 7, Unit 7.1 for this, because there are some trickier problems. Thanks for listening.